Thank you, appreciate it. Yeah, my name is Nate Schutta. I work for Pivotal. I'm an architect/advocate guy. I wrote a piece earlier this year trying to kind of sum up my whole thoughts on what it means to be an architect and how we can try to do that job better. Just as a programming note, Paulina did ask me to go a little long this afternoon to give a little bit extra time for people to get out to lunch so we're not all rushing out there at the same time, so the queue will be a little shorter. So that is my intent, to try to go a little past our designated ending time to try to help with the other end of lunch. So let's talk about the cloud, shall we? You look around and you realize there's a lot of options here, you know, and if I ask 10 or 15 people, what does cloud mean to you, I'm probably going to get 10 or 15 different answers. That seems to be pretty much the norm these days. You know, I know a lot of folks are very excited about microservices, and maybe some people are starting to kind of backtrack a bit from that and say, no, we're going to do a modular monolith. And I certainly run into a lot of people who are very excited about containers. And of course, today, everybody seems to be very fixated on serverless or functions as a service. You know, I'm convinced that you can put pretty much any word in front of as a service and it works out. I had someone say to me a few months ago that I'm an architect as a service, and I think that's pretty fitting, although I did actually kind of sound out that acronym, and it was a little more insulting than I originally had intended, so maybe it wasn't a compliment, I'm not certain. Now, a lot of people are very excited about that these days, and for many of us, we're sitting here going, hang on a sec, I just finally refactored my application to be these cloud-native microservices, and now you're telling me that I need to throw that away and do the whole thing as functions. I mean, that doesn't make me very happy, and that makes me grumpy, and you know, maybe you're old enough to remember this particular emoji that some of us have used. My wife saw this slide and had to ask me, what is that? And I said, well, it's table flip. She said, I don't understand. I said, see, arms are up in the air, the table's flipped over, it's table flip. And she just kind of shook her head and walked out of the room. I'll admit, I use this enough that I actually have a shortcut on my keyboard expander to do this, so I don't have to actually try to type it out. So let's not throw away that code quite yet. In fact, we can actually leverage most of that. And one of the points I'll make as we wrap up here today is all of these things are just tools. The challenge for us as technologists, as architects, as senior engineers, principal engineers, whatever your role happens to be, how do we choose when to use which tool? When do we use the tool in the right place? You know, too often I see folks grab a technology and use it for no purpose other than to put it on their resume. We don't think about the implications and when is the right place to use this particular tool. That's the real challenge for us. So I'm going to do a little bit of a historical walkthrough here to kind of help you sort of set the context of how did we arrive at where we are today, and just to kind of get us all on the same page in terms of what these different abstractions give us. So when the cloud first kind of became a thing, when we first started talking about it in a lot of organizations, what they really meant was IaaS. And it's been really fascinating to see how infrastructure has changed over the course of my career. It's been this really massive shift. You know, when I first started in software, all our servers were homegrown. I mean, almost to the point where we would order the parts and hand assemble them. They were very bespoke, very artisanal, and that was great for like a sandwich or something, but not so awesome when it came to hardware and software. But we would spend all this time, effort, and energy crafting them, and of course, it could take weeks, even months to get a new server instance. You know, and this is always a fun question to ask people. You know, what was the longest request to ready experience you've had in your career? You know, I think for most of us, you know, months is usually pretty normal, and usually, you know, I'd ask you to raise your hands, but I can't actually see you, so I won't know what you're doing. But, you know, most people would say, oh yeah, 3 months or 6 months or 9 months. I had one instance in my career where it took a year for my internal IT group to turn over a server to us. And we wanted a development database, and it wasn't even a very large database. It was just gonna hold some architectural artifacts, and it took a year for that to be available. I don't know what took that long, honestly. I mean, perhaps they were writing their own database software, I'm not really sure. But we've all had these kind of experiences where it's like, how could it possibly take that long? And of course, one of the big challenges that this gave us is that when we started a project, we had to answer a whole bunch of questions at a point where we had the least amount of information. So one of the most common questions that we get asked by our infrastructure folks when we're starting a new project is, well, so how much capacity do you think you're going to need? What is your capacity needs? And of course, our answer to that had to be something like this. I don't know. because we just don't know yet. We don't have enough information. And so what we would typically do in these situations, we'd do some educated guesses. We'd say, well, what's our worst case scenario? And then we'd usually double that. And then we'd add a little more, and then add a little more, because it was far easier to over-allocate in the beginning and not use all that capacity than to be wrong and have to come back later and beg for more, realizing it would take weeks or months to get additional capacity. And of course, that wasn't the only problem with this approach. We had to fill out lots of tickets, and you'd have to go to lots of meetings, and you'd send lots of emails, and there'd be more tickets, and there'd be more meetings, and there'd be more follow-up. It was not a very pleasant experience. Now, in this era of software, we would give our servers pithy names. We'd call them things. I worked on one company where our servers were all named after Simpsons characters, so I kind of enjoyed that. And so we would literally treat these servers like pets. Right, so these are my pets. These are my cats. This is Han and Chewie. And I'm pretty confident that if either Han or Chewie were to come down with any kind of ailment, my family would compel me to spend a significant amount of money trying to get them happy and healthy again. Because they're our pets, they're special to us, they're practically members of the family. And at this era of our careers, we would do whatever it took to keep our servers happy and healthy, because we spent all this time handcrafting them. They were expensive resources, they're heavily constrained resources. You know, we had this significant expense here, and so it was on us to get as much money out of that as possible. And so this is why people started creating things called app servers, because this allowed us to put as many applications as possible on that server. And so this would give us a maximum return on investment. But of course, there's some unintended side effects of shared hardware, shared resources. You know, all of a sudden now when I'm in this sharing situation, if your application has a bug, that's going to affect my application. If we need to coordinate changes, all of a sudden that becomes much, much more challenging. And if it's just my server, I can do whatever I want with it. How many of you have been in a situation where you really want to update to a new version of Java, but you can't because somebody else in the company is still using a really old version of Java and they don't ever want to upgrade, and so now you're stuck? I had an application several years ago, but we wanted to be on kind of the new strategic single sign-on solution. And so I was talking with my security guys, and I said, you know, when is this going to be available? And they said, oh, it'll be available in May or June. I said, fantastic. That's about when we want to go to production. They said, okay, well, in order to get on the new single sign-on solution, you need to also make sure your servers are all upgraded to the latest Windows image. And so I worked with the team that was coordinating all that, and they put my app group got put in that initial sort of wave, and I'm like, great, this is awesome. And then I went back to my security guys a couple months later, and I'm like, so what's it going to take? And they said, oh, well, it turns out the infrastructure team isn't going to allow any changes at all to any of the images until every server in the company has been updated. So you can't have that single sign-on solution until May or June of next year. So my poor application had to sit on this tactical solution for over a year because, well, we have to wait for everyone else. You know, this is why we can't have nice things. I had one application, I came in on a Monday morning, one of my apps was down, and we started digging, and we discovered that every application on that server went down, except for one application that had put in a MIME type change over the weekend. And so that application was fine, but everybody else got whacked. Now, I have no idea how that wasn't caught in a lower region, neither here nor there, but this is why for so many organizations, currency was not something that we cared a lot about, or we sort of kicked that can down the street, because it's 18 months of frustration and freezes and testing, and things aren't going to work, and so you're like, you know what, that's just not worth it. Which, of course, makes me think about this famous Yoda quote, you know, fear is the path to the dark side, fear leads to anger, anger leads to hate, hate leads to suffering. I had no idea there was such a thing as Yoda ops, but certainly it feels like there is. And so if we think about this era as well, I mean, the part of our challenge is that we are moving code from one physical instance of a server to another physical instance of a server, which meant we would inevitably have an experience at some point where, well, it worked in dev, but not in test. That was always fun. You know, or it works in test, but not in QA, or works in QA, but not in main, or whatever. And so you'd sit there and you'd have to try to figure out, like, what is different between these regions? Because conceptually, the environments are all supposed to be the same. It's the same app server. It's the same underlying operating system. How could this not work? I had one situation, we spent at least 2 weeks trying to figure out what was different between these regions. And after lots and lots of digging and looking at various things, what ended up being the only difference was the order the patches were applied. And you just think to yourself, why do I do this to myself? You know, is it time for me to try a different career? You know, I mean, Do electricians or plumbers or carpenters deal with this kind of stuff? Probably not. I don't know. And so the shift started to happen as we realized this is not a great way of doing things. And technology changes helped, of course. Our servers started to become commodities. And so we started to rely on Linux and Intel chips instead of these custom hardware and custom operating systems. And unsurprisingly, prices started to drop. And servers were no longer the constraining factor. It turns out people were the more expensive part of this equation. But as things like Heroku and AWS and App Engine and Cloud Foundry and Azure started becoming more commonplace, we started to realize that actually shared servers are a liability. The right way to treat our servers is like cows. When a cow gets sick on a cattle farm, you put the cow down, you get a new instance of cow. You don't give cows names, you give them numbers. And so if 15 gets sick, we don't spend a lot of time and effort trying to make 15 feel better. We just get a new 15. Now that's not entirely true. I actually grew up on a hobby farm, and so we actually had a couple of dozen longhorn cows. And so we did actually kind of treat them like pets. We had one cow in particular, her name was Houdini, because she knew how to get in and out of the pen at will. Like, she never went anywhere because she knew that's where mom was and that's where food was. So she was just kind of like, I don't know if she's just showing her, ability to have some independence or what. But I remember I was sitting in my living room and I kind of feel like there's something watching you. And so I kind of looked over my shoulder and here was this 300-pound calf standing on my back porch just sort of staring at me like, hey, what's going on in there? So she was a fun cow. But, most of the time, this is not, in fact, how we treat cows. Now, the reality of this is we started to introduce greater automation. We started introducing tools like Chef and Puppet and Bosch, and we started treating infrastructure like code. Because if you've ever noticed, human beings, we don't do the same thing twice, ever. We're just not capable of it. If you don't believe me, go try playing a sport like golf. It's almost impossible to repeat. And so that's fine in a sport, in a hobby, but when it comes to infrastructure, when it comes to software, I want consistency. The beauty of treating infrastructure as code is a script is going to do the same thing every single time. It won't deviate. It won't get bored. It won't skip a step. And so inevitably, as this level of automation started to take hold, our lead times dropped, and instead of it being months, it was weeks. Instead of weeks, it was days, sometimes even self-serve. And let's be honest, at least part of this in a lot of organizations was a direct reaction to what people were able to do with public cloud providers. So more than a few companies recognized, hey, wait a minute, I can actually spin something up on Google's cloud platform way faster than trying to get my internal infrastructure people to do it. And so this is where we started to see shadow ops kind of organizations appear, and teams would just go rogue and they would just sort of spin something up really quickly, because it doesn't take very long. You can get an instance up and running in a matter of seconds and just need your corporate credit card and away you go. So the idea here in many organizations was, hey, let's bring some of that automation in. Let's give people that same kind of speed, but let's do it on-prem. Maybe it's even self-serve on demand. Most of, at least what I experienced in this era, it's just the same thing, only faster. Of course, how do we do that? Well, it's virtualization. Push comes to shove. We just put abstraction over that physical compute resource. It gets managed with a hypervisor. And it gives us a really coarse-grained component, which is still useful today if I need that level of flexibility, but we need to understand that that's then more for us to manage. And so one of the points that I try to hammer home to people when we're talking about these sort of different approaches we can take is, with greater power comes greater responsibility. And so yes, you have a lot more flexibility in that environment, but there's much, much more for you to manage. Now, there are still instances where we need that today. Because we need specific ports or we need specific hardware configurations that just don't happen unless we do it ourselves. But this rarely should be our first thought anymore. Now, that said, this is still ultimately what lives underneath what everyone calls the cloud today, is some kind of infrastructure provisioning that doesn't involve lots of people going and doing lots of things by hand. Now, on top of this, we started to leverage containers. And so most people, when you say container, they think Docker. And a lot of people are still very confused about what Docker is. At its core, Docker is a box. Right? It is literally like a shipping container, and when you consider how revolutionary the shipping container was to being able to haul things across the oceans, you have very similar concepts here with Docker. Kind of before the advent of shipping containers, there was lots and lots of manual labor involved in taking things on and off a ship, and it was also very slow, whereas here, you put it in this box, crane operator loads the box onto a container ship, and then a container ship takes a voyage. Now, the beauty of Docker, the beauty of a container box like this is you just put whatever you want in it. And so for us in the software environment, what that means is I put everything I need for my application to run inside this one abstraction. So here's the code, here's all the libraries, the executable, any settings, anything else, and everything is in this one little instantiation. Now this is what I want you to run. And so that fully isolates us from our environment. We don't have to worry about, oh, somebody installed this server slightly differently than they did over here. It's like, nope, everything is inside this container. Simply execute this image for me. And again, how often have we had that experience in our careers where one environment doesn't match another? One of my friends actually got so tired of hearing people say, works on my box, that he had stickers made up. And if you uttered that in a meeting, he would slap one of those on your laptop. And it was not meant as a compliment, by the way. So in this environment, instead of copying code from one place to another, I'm going to define everything I need inside that box, and it's that box that I'm going to move from one environment to another. So very similar conceptually to a virtual machine. The big difference is, where would you say we're virtualizing? So instead of virtualizing at the hardware level, we're virtualizing at the OS level. Now, the flip side of that is you have to tell Docker everything you need. And so this again gets back to, with greater flexibility comes greater responsibility, imagine that. And so we have to create a Docker image. This often lives up on Docker Hub. Docker Hub is community driven, which means it is not vetted, it is not curated. So anybody can push anything at any time, including please turn my computer into part of your botnet empire. Now there is also the Docker store, which does exactly what you think it does. It allows you to sell images so people can put things up there that they believe in, that they want to support, and then now they can actually make a financial transaction out of this. And so these things are vetted, are curated, and are generally backed by a large commercial entity that then will provide you some level of support along with that, and may or may not require additional licensing. So these are things that have been approved by Docker. These are things that, again, are generally supported by those entities, and it is going to involve some amount of money trading hands. Now, you'll also notice if you poke around on the Docker Hub, there are Docker certified images as well, and some of those come directly from Docker. And so this is all based on the Docker public registry. Now, some organizations will run their own internal registry. That's fairly common as well. Usually it's based on the same technology. And of course, you might ask yourself, well, what the heck is an image? Well, an image is just a way of saying, you know what, here's a template or a recipe that I'm going to build this container from. In general, we tend to customize these from existing images, and so you can think about it just like inheritance in a Java class or in any language that has inheritance. I'm going to go ahead and use that as a starting point, and then I will customize from there. Now, again, I want to stress the big challenge here is you are responsible for everything that goes in the box. Always think about Uncle Ben whenever you think about trying to do this kind of an environment. You have to make sure stuff stays current. One of the things I tend to see in organizations is they'll end up having sort of lots of Docker images all over the place, and nobody has the same thing twice, and nothing looks the same, and everybody kind of has their own special little sauce that they've dribbled over it. And there are advantages to that, there's disadvantages to that. And so it tends to be a bit of a thing that you may have to think about in terms of governance. And of course, you really do need to think about currency. I think this is finally starting to get the attention it deserves. You look at the Equifax hack, which is, put whole tons of people's personal information out on the internet. Equifax actually got shoved aside not too long ago by Exactus. There's a company I'd never heard of before. So I think that's like 340 million records. I have a good friend of mine that's a security guy, and anytime I ask him any questions about this, it makes me feel very concerned because he knows, he's been exposed to things that I probably don't want to know about, and I always kind of walk away thinking I should just sort of like go get like a house out in the middle of the woods that doesn't have an internet connection. That's probably the only way to truly be safe these days. But I think the level of issues we're seeing is getting more fascinating as well when you start talking about Meltdown and Spectre and some of these things that are at a really low level and that they aren't vulnerabilities in terms of somebody made a mistake in how they wrote some software and it's easy to patch. Some of this is pretty integral to how we do things. And of course, it's important that we understand that in these environments, we're responsible for staying current if we're running a whole bunch of Docker containers. And so what does that look like? Do we have the staff for that? Now, of course, as soon as you start talking about containers, somebody eventually says Kubernetes or K8s, which is a way of deploying, scaling, managing containers. And of course, part of what gets people very excited about Kubernetes is it did come out of Google. And so as you're all aware, this is not Google's first rodeo. They know how to do these things. They have deep, deep experience here. And so Kubernetes gives you many of the features that you would expect in this kind of an environment: self-healing, scaling, service discovery, load balancing, rollout, rollback. And the level that most of us work with Kubernetes would be at the kubectl or kube control or kube cuddle or kube cuttle. Everybody seems to have a slightly different emphasis on how they pronounce this. It's just the command line. The beauty of Kubernetes is you tell Kubernetes, this is what I would like, please make it so. You know, put your favorite Captain Picard reference here. But Kubernetes gives us a number of useful abstractions. There's pod, there's service, there's volume, there's namespace. Pod is what a lot of us think about when it comes to an application. This is something that houses one or potentially more than one container. This is where you're going to get your storage, your unique IPs, et cetera. Pod is basically the unit of deployment. And so for most of us, we would equate this with an instance of an application. Now, most of the time when people talk about what kind of container are we going to run here, they usually mean a Docker container, but it certainly doesn't have to be a Docker container. And while I mentioned this before, you know, it's very common to see only one container in a pod. Every so often you run into a situation like, you know what, these two containers are really tightly bound together. I'd like them to be deployed together. All right, so I want them to be able to share resources. I don't want them to have to communicate by going all the way outside and back in. I want them to be able to talk right next to one another. And these are typically referred to as a sidecar. Now, basically, everybody has a K8s option today. Of course, there's Google's Kubernetes engine. Amazon has EKS and Fargate. There's Kubernetes on Azure. There's PKS. There's just no shortage of options when it comes to running Kubernetes. One of the big things I want to stress: managing a Kubernetes cluster can be challenging. It is not as simple as some people make it out to be. Now, usually getting one up and running is fairly straightforward. It's the, hey, look, a new version of Kubernetes came out. Oh, hey, look, a new version of Kubernetes came out. Hey, look, a new version of Kubernetes came out. How do we get that applied without taking down our production environment? Now, the beauty of this, it gives us another set of primitives to work with and another way of sort of working in these environments. Now, built on top of these concepts, you can then use something like an app platform. So this is usually layered on top of IaaS, and the goal with any kind of application platform is to say, you know what, developers, the thing they should care most about are applications. Not dial tone, not middleware, not any of those kind of things. Just focus on pushing applications to the cloud. Let the environment figure out how to do the rest of it. Now, the concepts are similar across all of these. I'll speak about Cloud Foundry since that's the one that I know best. So Bosch sets up a pool of VMs. This gives you a pool of compute. There's a cloud controller that says, all right, you'd like me to deploy an instance of your app onto this pool of compute. I know I've got some free space over here. I'm going to deploy it there, and I'm going to go ahead and update this routing table because this is where it physically is, and then the router knows how to direct traffic to that specific instance of your application. Now, the beauty of this environment is, as a developer, all I have to worry about is the application. I write my code. I don't have to worry about how to set any of this up. The runtime comes from the platform itself. Now again, we think back to the old way of doing things. I would move code from one instance of one app server to another instance of another app server. And inevitably, we'd have the wonderful worked in dev, not in test, which, to revisit some of my previous slides, makes me very angry. Right? And for sure, I've done this on more than one project before. Now, instead of moving code, let's just move the whole runtime. And so again, much like a container, it's a much coarser grained thing. And so in a platform environment, if it worked in dev, well, don't worry, that's the exact same thing we're going to run in test. In fact, in most situations, we haven't changed anything other than updating the routing table. So an entire class of issues just vanishes from beneath us. We don't have to worry about them. We don't have to deal with them. We get consistency. That's huge for us. Again, artisanal bespoke is fantastic when it comes to lunch or dinner or something like that, or perhaps a really fashionable bit of clothing. But when it comes to my servers, when it comes to my application environments, I just can't afford that level of inconsistency. So I'm sure many of you are familiar with the 12 factors. Of course, number 10 says, I want dev prod parity. I need consistency between my environments. And so the goal with a situation like this with a platform is, how do we shorten that code to prod cycle? Right, so that's always a fun sort of mental exercise to do. Like, how long does it take in your environment for a customer to identify this as a problem, you fix it, test it, and it gets deployed into production? Now, in a perfect world, that would be a really short amount of time. And we can sort of debate about like continuously delivering code, like developer hits commit and some number of minutes later it's in production. I don't think that's super practical for most of us. There's usually gonna have to be some human intervention somewhere in that deployment pipeline. But we can certainly shorten that down. You know, and I've actually done this in various organizations, and in one of my own personal experience, I had one situation where it took us like a month to go from customer has idea to it's running in production. And that's a long time, especially when you realize how much of it is just sitting there waiting for like release weekend to happen. Now, it's important to ask yourself, like, where does the runtime come from with a platform? And at least in the terms of Cloud Foundry, that's from the build pack. And so you do a CF push, and it says, all right, I know what kind of runtime based on information I glean about this project or what you tell me about the project. And so it'll go ahead and grab that particular build pack, deploy your application inside of it. This gets turned into a droplet, which then gets uploaded to Cloud Foundry, and Cloud Foundry says, oh, I see I've got some space over here, and pushes that droplet to that particular cell. Now, the build pack has everything you need to run the app. And what that does for us is pushes the value line up. So it gets us out of doing this undifferentiated heavy lifting. Right? So the typical way to think about this is the sort of infamous Anzi haiku. Here's my source code, run it in the cloud for me. I do not care how. You know, to me, that there's a lot of value in that, because I just want to write code. I don't want to think about what version of what runtime and what needs to be installed where. And you know, it's much more powerful if I can just do this one little command and away we go. So my personal website actually runs on PDubs, and so it is a static website, so it's running on Heroku. I've never set up, or I'm sorry, not Heroku. It runs on Nginx. I've never set up Nginx. I'm sure I could if I had to, but I'd really rather not. And so I can just do a CF push when I have a new version of my application ready, and it goes ahead and figures out, okay, this happens to be the static build pack, that happens to be Nginx. And so without me having to know anything about how to install or configure or where my code needs to be, it just does this all for me. And one of the most powerful aspects of this for me is fairly often when I do an update to my website, I'm getting a new version of Nginx. And I don't ever have to care about that. It just works. And if it turns out there was some critical vulnerability, it wouldn't take much for me to fix that. I would basically just redeploy my application, pull down the new build pack, and I'd have the new setup, I'd have the new configuration, and away we go. That to me is a win. Now, could I set this all up? Probably, but it's not something I'm interested in. I just want my website to run. And so I think about it the same way with code. It's like I'm just trying to solve a business problem. I don't care about all the setup issues that go into this. And in a matter of a few minutes, I go from my app's not running to, there you go, my app is up and running on a brand new version of Nginx. Now, of course, you may look at that and say, but obviously I'm not able to customize that. It's whatever the off-the-shelf Nginx experience is, and that's true, but I could customize the build pack if I wanted to. I could make my own specific Nginx build pack or Java build pack or .NET build pack. But then, of course, the answer there is, should I do that? Now, there's 3 answers to every question you've ever been asked in computer science. There's 42. That's to see who's read Hitchhiker's Guide. Another layer of indirection. That's my favorite as an architect. But, of course, the answer I reach to the most is, well, it depends. I mean, it depends. I mean, there are absolutely instances where the right answer is, yes, you should build your own customized build pack. I mean, I've been in that situation. My previous employer, we had our own custom build packs because we had specific things we needed for some of our heritage applications, and the easiest way to do that was just have 2 or 3 custom build packs. Your first reaction, of course, should be, is that really something we want to do? Because as soon as you go down that path, you build it, you own it. And you are signing up for a long-term maintenance agreement that comes along with that. And of course, you're also signing up for a currency agreement that comes along with that. So now you're going to be responsible when something like this happens in 6 months or 18 months or whatever it happens to be. Again, the whole point of these platforms is to say, you know what, don't worry about that undifferentiated heavy lifting. Just take a step back and ask yourself, what do your customers want? What do your customers value? Do they care about the runtime? I mean, do they even know? I mean, probably not. They shouldn't care. I mean, that worries me. I have been in some situations where my customers were actually asking me questions about like WSDLs and stuff like that. It's like, whoa, you're getting way too down in the weeds. This is not something that you should ever worry about. And you don't ever get, your customers don't bake you a cake because you updated the operating system from this version to that version. They don't care. That's total dial tone to them. They want features. They want problem solved. They want new feature sets, new defects fixed, things like that. And so the beauty of using a platform is it says, you know what? Don't worry about that underlying stuff. Focus on solving business problems. Don't worry about the plumbing. Now, there's a lot of different options here. There's Cloud Foundry, there's Heroku. You can build some of these on top of public cloud providers as well. But again, it just moves that value line for us and allows us to focus on the things that our customers ultimately care more about, which is features and functionality, not the underlying dial tone. Now, of course, this world never stays the same. We're always kind of adapting. Life moves pretty fast, to quote Ferris Bueller. And so we've seen this shift from IaaS to CaaS to PaaS, and now we're talking about serverless or functions as a service. And of course, we were talking about this earlier this morning. There are still servers. All right, this is not a great name. Some people seem to think this is the case. It's amazing some of the misconceptions people have about our environment. I was working with one of my customers a couple years ago, and they were telling me that, well, there's no way we can possibly be on AWS. And I said, oh, really, why is that? Well, because then someone could just go to Amazon.com and they'd find our data. It's like, that's not how it works. I'm sorry to tell you that. So just because serverless happens to be the sort of the term of the day does not mean there are no servers. I mean, this still has to run on physical hardware somewhere. It's just we don't care where that place is. We're further abstracted away from it. So we're no longer responsible for provisioning servers, updating servers, scaling servers, et cetera. We make that someone else's problem, not ours. Now, my friend Sam tweeted this out, and he makes a great point that in these environments with hardware, an operating system, and a hypervisor, and a VM, and Docker, and containers, and your application, every single one of these needs to be patched. Haven't we just made things much worse? And he's not wrong, all right? We have. But that prompted a reply from my friend Josh, who said, well, you're right, Sam, but this is why we have the platforms. This is why we have things like Cloud Foundry. This is why we have the public cloud offerings, because they take responsibility for that so that we don't have to deal with it. That's a huge step up for us, because, again, these are all still part of the equation. Those haven't gone away, as much as we may want to pretend they have. And so I think it's useful to sort of think about the blocks that we have here. And again, IaaS is still part of this. It's just for most of us, we never really need to deal with it at that level. And so what we need to think about is, what do each of these abstractions give us? What are we responsible for, and what comes from the platform? So if we think about containers, we have to bring the container to the party. And our application goes inside that container. And the container environment, the platform, gives us the scheduling, gives us the primitives for networking, metrics, routing, et cetera. If I use a platform, well, I still have the container, but I'm not responsible for it anymore. I bring an application to the party, and that application sits on top of this platform, and then the platform gives me the images, the networking, logs, metrics, monitoring, a marketplace, maybe some quotas. But I'm not responsible for the container image anymore. I'm just responsible for my application. Now, if I go up a notch to serverless, the container, again, kind of comes along for the ride. I'm even further abstracted away from even knowing what a container is. All I need to worry about is a function. That function might only be 3, 4, 5 lines of code, 20 lines of code. So that's pretty small. And I let the environment worry about, how do you execute that function? How do you scale that function? How do you deprovision it, bring it back up when somebody makes a request? How do you bind to that event stream? And so the difference in all of these environments is, what am I doing as a developer versus what am I getting from that platform? What am I getting from the tools? It's just different levels of abstraction. Different problems fit in different buckets based on what we're trying to do. So that's all we're talking about here. Now, another way of visualizing this would sort of be this layer cake idea, which is, all right, we've got hardware at the very bottom. On top of hardware, we use IaaS to provision that hardware quickly and consistently. On top of IaaS, we use containers to make sure everything is the same, everything looks the same. We bring everything we need inside that container. We build platforms really utilizing that concept, and then serverless kind of sits at the very top of this whole thing. And the moral of the story is, kind of the lower down I go in this particular approach, I have more flexibility, I have control over more things, but there's also fewer standards. Whereas if I go up the abstraction, it's easier. There's less for me to worry about. There's less complexity. I get some more operational efficiencies. I also have less flexibility. There's things that I can't do in a serverless environment that I could in a container, or I could at the hardware level. And so the general advice that I typically give people is push things as far up the stack as possible, realizing that not everything fits in each bucket. Now, a lot of people would argue that serverless is the new PaaS. There are no shortage of options here. There's Lambda, there's Azure Functions, there's Google Cloud Functions, there's Knative, Riff, Kubeless, Fission, OpenWhisk. This very much suffers from the shiny new thing curse. In our industry, we tend to be like dogs chasing squirrels. You know, it's like, ooh, shiny new thing, ooh, blockchain, ooh, machine learning, you know, and we just kind of chase after it, trying to find a way to jam it into our next project. So be cautious here. I see a lot of people fall into the proverbial lemming effect, which is to say, I read a white paper about functions, now I need to use functions on my next project. Now, I would argue FaaS is really a subset of serverless. Some people do use the terms interchangeably. I want to stress there are some really, really good reasons for using this particular approach. Some of it is specifically platform related. You know, let's say you've already got a bunch of data with a provider. Maybe you've got a bunch of stuff sitting on S3. You might want to like roll through that, writing a function, running that on Lambda can be a very powerful way to do it. You know, maybe there's a particular bit of functionality that one of the providers offers that you want to take advantage of. You know, maybe you want to use machine learning from Google. You know, that's another typical application of things like this. But I want to stress this is not just some shiny new way to cloud. All right, we're talking about some really serious efficiency gains. There's some really serious development efficiencies here. Because I'm just writing a function, now we're talking about 10, 15, 20 lines of code. And so that's even less for me to get my head wrapped around. I'm even more focused on implementation as opposed to infrastructure. And I always kind of like asking or quizzing people on this, like, you know, do you know what operating system your application is running on? I mean, you probably know it's a Linux variant, but do you know exactly which distro? And, you know, do you know what patch version you're running on? And more importantly, do you care? I mean, I think it's important for us to ponder, like, what matters for us? What is the things we should be caring about? Where's the value line for us? How do we get out of as much undifferentiated heavy lifting as possible? Because we want to focus as much as possible on business problems, not plumbing problems. Now, the other thing that gets people very excited about serverless is resource efficiencies. Because if your function has not been called in some period of time, we can terminate the container. And so if the container's terminated, you pay nothing. And so when a request comes in, we spin up a new instance of the container, and away we go, which a lot of people then equate to saying, oh, well, functions are free. Well, they're not. I mean, most of the providers give you a pretty large chunk of free functions, although I want to be honest with you, $1 million or $2 million is something you're going to roll through rather quickly. And there's always a big asterisk at the end of that, which is additional fees may apply. So they might give you the function itself for free for a certain period of time, but then there's this random fractional, I shouldn't say random, there's a fractional cost that seems like a random number, because it's like 0.00068923145. Usually pi is embedded in there just to be cute. And then, of course, there's the other fees that go along with maybe data transfer or any other services you might have used. Now, if you look at all the providers, the way they charge you for this is based on the number of requests, how long that request ran, and how much resource you needed allocated for that. And there's always a limit on how much resource you can have as well. You know, these things typically have a fairly small footprint. I will be honest, it is hard to figure out exactly how much this is going to cost you. You're probably going to have to grab a spreadsheet and do some modeling to try to get a rough sense of if we had this many requests, what would it look like? If we had this many requests, what would it look like? But for certain workloads, it is as cheap as it gets. There's no getting around it. There's some pretty serious operational efficiencies as well. Some people refer to this as serverless ops. Of course, it's not really true. It's just we're abstracted away from it. It's less for us specifically to worry about. It's something, again, that the platform does for us. There's a lot of good use cases for functions. If you're in a situation where the business requirements are rapidly iterating, I mean, talking about every couple hours, seemingly, they've got a new idea on how to change things. If you've got stateless workloads, this is pretty spiffy. If these are infrequent or sporadic requests, or it's really hard to determine exactly what that pattern looks like, anything where you've got really variable scaling needs tends to fit nicely. Asynchronous is your friend here. You know, you see a lot of people talk about slow startup time. That usually means you're trying to do something synchronous, so maybe not the best choice. Easily to parallelize. You see it a lot with machine learning, IoT, log ingestion, batch processing. Most of the conversational UIs that you're dealing with, you know, your Alexas, your things like that, are almost always using some kind of a function as a service in the background. CI/CD automation, chat integration. I read one thing earlier this year about a company who had like an agent basically watching Stack Overflow, and if anyone asked a question about their product, it sent an alert to the development team to go look at the Stack Overflow question. A lot of website backend stuff can actually fit nicely here. Event processing tends to be a pretty good fit. Monitoring, alerting, scanning. You know, the example I typically give is if you go to your bank or your cell company or whatever, and you update your address, some period of time later, you're probably going to get an email from them saying, hey, we noticed someone made a change to your account. If that was you, ignore this email. Otherwise, please contact support. That's a perfect use for a function, because it doesn't happen thousands of times a second. It's sporadic. It doesn't really matter whether that email gets sent out 5 seconds after you update the address or a minute and a half after you update the address, because it's an asynchronous thing anyway. All right, so this is a very valuable tool. It's a wonderful part of our toolkit. It is not, in fact, the answer for everything. Now, I just saw this tweet, and I'm sorry, this is one that I wrote last year, sorry. This isn't the right answer to everything. All right, as soon as you have latency sensitivity, serverless is the wrong choice. And a lot of people like to equate it to the language. They say, oh, you can't use Java for serverless because Java is slow. That's not true. If you don't believe me, Dave Sire just did a presentation at Spring 1 a couple weeks ago where he showed that Spring is very fast, Java is very fast. You know, so I get a little upset when people blame languages for these problems. When I see people complain about slow startup time, it has nothing to do with the language. It has to do with the fact that they chose serverless in an environment where it doesn't make sense. All right? That's hopefully not a shock to any of you. I'll briefly touch on Spring Cloud Functions, try to close that loop here. This is, as you might guess, a Spring take on functions. And one of the goals of Spring Cloud Functions is to abstract away the runtime. So again, in typical Spring fashion, you worry about the code, and that same code can work as an endpoint, as a task, as a stream processor, trying to give people a unified model across the different providers. All right, whether you're doing it today or not, there's a pretty good chance you will at some point get into polycloud or multi-cloud, however you want to phrase it. You know, and of course, a lot of us have data centers, and we're still going to run some of these things locally, so being able to have this flexibility is a good thing. And so there's lots of strategic and tactical reasons why we might choose one provider over another, and it's very helpful to be able to bring all the wonderful Spring Boot features that we've come to know and love to serverless. Now again, as I keep repeating here, the whole goal is to let you focus on writing a business logic. In the case of Spring Functions, it uses the core abstractions from Java util function, so function, consumer, supplier. You can also use Flux if you wish. So yes, you can do this in a reactive manner if that is your cup of tea. This can also be converted into string-based lambdas if you wish. Now, it's fair to ask, if this is just standard Java stuff, why should I use the Spring variant of it? It gets back to quite frankly, why most of us use Spring, which is inversion of control. All right, so the idea here is allowing you to decouple the code from that deployment profile, so you simply add the right dependency, and we take care of the rest. So you want that to be a RESTful endpoint, no problem, use Spring Cloud Function Web. Or you'd like that to be a stream processor instead, we can handle that, Spring Cloud Function Stream. So I don't know about you, but I hate boilerplate, and so anything that removes boilerplate from my life is a good thing. And so again, part of the whole goal here is how do we allow you to focus on functions, let the framework handle as much as possible beyond that, and then now you can implement and test your code in your target environment. Now, speaking of sort of poly-cloud functions, I want to talk a bit about Riff. All right, so Riff is an open source, sort of cloud agnostic function provider. Riff is a recursive acronym. Riff is for functions. Isn't that cute? This is FaaS sitting on top of Kubernetes, built with Knative. It comes out of the experience of the Spring Cloud Streams and Spring Data Flow projects, so it's a lot of the same committers are working on that. The whole goal here is to let you write polyglot functions that will scale up, scale down as necessary. Now, one of the interesting things that the Riff guys talk about is this notion of ICE, which they sort of, realizing it's not really a theorem, say is similar to CAP for serverless. So when it comes to these serverless environments, you can have immediate, you can have consistent, you can have efficient, you get 2 out of the 3, but not all 3. And so it kind of challenges us to figure out what are the concerns we care most about. Do we want resource utilization? Do we want immutable containers? Ultimately, it's a set of compromises. So to avoid slow startup experiences, that cold startup experience, a lot of folks will say, well, let's just keep our container running all the time. Well, now I'm paying for resources I'm not using, and one could argue I've essentially recreated a PaaS. Is that really what we want to do? If I'm injecting code into a warm container, I don't have immutability anymore. That might not be what we're looking for. And of course, if I launch a container on demand, well, now I'm dealing with that cold startup experience, which can cause a bit of an issue. Although again, I would argue if this is your problem, you've chosen the wrong abstraction. And I saw this tweet. This is the one I thought I was going to show you earlier. I saw a talk earlier that suggested a best practice is to write a second cloud function that constantly pings the first cloud function to make sure it never shuts down. This seems like a really bad idea. I agree with the tweet that we've reinvented the server. This doesn't sound like the right approach. When I saw this, that someone had actually said in a talk, this is a best practice, it made me, ponder a bit, like, who thought that was a good idea? Now, in fairness, what a number of the environments actually use is dynamic loading. And so they keep a pool of containers warm. The request comes in, it notices they don't have one to handle your particular request, and so it injects your code into an already warm container. The goal with Riff is to say, you know what, you get to choose the trade-offs that make sense to you. And one of the things I appreciate about Riff is it's very, very thin. You write functions that you deploy and run as Knative services. The CLI actually builds on top of the Knative CLI as well as the kubectl CLI. And so you can create your function either directly from source right there on your machine, or you can go pull it from a repository if you wish. It's going to create a Docker image on your behalf, which you can then push up to Docker Hub if you want, or GCR. It's up to you. I've been playing around with Riff since it first kind of came out over the winter, and it's been fascinating to see how it's evolved. I mean, when it first came out, you were responsible for writing the container, and you were responsible for writing all the YAML. It's gotten to the point now where, especially with Knative, once you get your Kubernetes cluster running, you get Riff installed on there. All you literally have to do is write the function and then say, create me the function, and it goes ahead and creates the image for you, pushes the image out there. It's far less for you to manage. Right? And when you rebuild, if you change the code, it says, I see this as a new version, and it will create a Knative revision. There is also a matching CLI for subscriptions. That's your queues, your topics, so you can create, delete, etc. I can't stress enough about how much this is evolving and moving. I had this working on Friday, and I was going to show it to you, and then I got on an airplane, and now it broke, and I'm not sure why. I've been playing with it all morning, and I keep getting interesting errors, so I'm not actually going to try to demo this in front of you and show you an error. That doesn't make a whole lot of sense. But ultimately, what we're trying to do here is give you an agnostic layer that runs on top of FaaS. So you want to run it on-prem? Great, awesome. You want to run it in your favorite public cloud provider? No worries, and you can change that out as either tactical or strategic reasons crop up. So under the hood, Riff lives on top of Knative. So Knative is a very new project that came out of Google, and it's all about the fragmentation in the functions space. So if you go to the Knative website, they're going to say it's all about building, deploying, and managing modern serverless workloads. Riff has sort of adopted this very similar language, saying it's a bunch of APIs to help you deploy these serverless style functions as well as applications and containers. Push comes to shove, it's middleware. The goal is to let you run this anywhere, anytime. It'll handle the orchestration, the routing, the traffic management, etc. As you can guess, it will scale up and scale down to 0 as necessary. This is really just an agnostic layer on top of FaaS. All right, so this is built on top of Kubernetes and Istio as well. Istio is what provides kind of that networking backbone. And there's three kind of major building blocks that Knative gives us. So there's the build, and this is a pluggable building approach for building containers. And so it's ultimately designed to be part of your CI/CD pipeline. It will do all sorts of different build methods. It doesn't have to be a Docker image. It can use a build pack. It can build Canico. It's totally up to you. Now, there's 4 main elements to the build. You've got to tell it where would you say my source code is, and again, that could be from a repo if you prefer. And then what are the steps actually necessary to build that container? What account is going to do that container build? And then what volumes do I have so that I can inject anything into that build process as necessary? Knative gives us an eventing portion as well. This is pub sub. You can think about this basically as Kafka. It could be Kafka under the hood. It's basically an abstraction over the top of the event stream, so don't worry about where the messaging is coming from. It leverages typical Kubernetes custom resources. So these are channels, otherwise known as topics. And then there's a bus, which is the actual provider. So that could be Rabbit, that could be Kafka, that could be Google Cloud Pub Sub. Looks a little bit like this. So again, your application, your function does not care what the underlying bus is. You publish to a channel, you subscribe to a channel, and then you let that abstraction worry about the underlying components. How do we really talk to Kafka or whatever it happens to be? And of course, Knative gives us serving. So how do we scale up? How do we scale down? So as we see more lag, scale up until we see less lag or no lag. And then as demand decreases, we roll that back down. And then where possible, go down to 0. Knative also gives us this idea of revision control. So Istio knows how to route traffic to different versions. So we could theoretically have 3 or 4 different versions of the same function running, which helps us do 0 downtime deploys, blue-green deploys, et cetera. I've talked about Kubernetes already. I've talked about Docker as well. So all these pieces kind of mix together to give us a really interesting environment. Now that leads to this amazing question, which is which of these many approaches makes sense for us? Well, you all know what I'm going to say next. It depends. All right, now I know a lot of people get mad at me when I say it depends because like, Nate, that's a glib answer and you're shutting down the conversation. I never mean it that way. I always mean it as like the first step in the conversation because now we need to start asking some questions and have a little back and forth to figure this out. Now, there is no one right answer here, I'm sorry. You know, I know a lot of people, they get very excited about something and they say, this is the answer to everything. I had somebody a couple months ago tell me they were going to refactor their entire application as a set of functions. I thought, ooh, that's a bad idea. You know, there might be, well, there are a handful of applications in the world that truly are nothing but a set of functions, but that is not the norm. That's the exception that proves the rule. The moral of the story, these are and not or problems. Not all workloads fit in every bucket. The challenge for us is knowing and understanding the trade-offs. And when should we put one workload in one bucket? Now, I've said this a couple times. I keep coming back to it. If I use an approach that gives me more flexibility, by definition, I have more responsible for what goes right or wrong there. I'm adding complexity. I have to think about what do I want my developers worrying about? Do we need to worry about keeping our containers updated? Or do I want them just to push an app or push a function? How many operators does it take to support an environment? If I have a consistent environment, probably not many. If I have a bespoke environment, it's probably quite a number. And so we have to constantly balance this sort of flexibility versus standardization. And we need to understand that guardrails aren't shackles. You know, if you've ever been on a windy mountain road, you might appreciate the fact there's a guardrail there. You know, they're ultimately designed to protect you. And so we need to ask ourselves, like, where do we want to spend our time, effort, and energy? And push comes to shove, you've got to choose the right option for the problem in front of you. And that's the way we need to look at all of these. They're just tools. So my wife and I are in the process of finishing our basement. And the subcontractors that are doing the work, when the carpenters show up, they don't just have one hammer. They got a whole truck full of hammers. And each one works in the right spot. If they're tearing down a wall, they're going to use a sledgehammer. If they're doing, you know, kind of the rough work of putting up the framing, they're going to use a different hammer than they are if they're going to do the finishing work, you know, with that beautiful maple trim. You know, if you try to use a sledgehammer to put up maple trim, it's not going to work very well. You know, and I saw this tweet from Richard Schroeder recently, and there's a lot of truth in this. You know, there's a lot of kind of seeming animosity in these spaces. You know, these aren't zero-sum games. There's not one runtime for all software. And that shouldn't be a surprise to any of us. You know, and Dave had a great sort of slide about this at Spring One, that they're all just sort of different sides of the triangle. And so the challenge for us is figuring out which workload makes sense in which of these buckets, and how do I want to allocate my resources. Now again, I would advise you to push as many workloads as you can, as high up the hierarchy as you can, realizing that for some things, the right answer is just put it in a box and run it. And for others, it's turn it into a function. And for others, it's rewrite it and make it cloud native. Now, I want to stress as well, this is a rapidly evolving space. You know, I would argue that functions are moving pretty fast. Riff itself is ridiculously new. There's a ton of material out there. I think they're going to grab the slides, so you guys don't need to worry about all these links, but there's a bunch of good videos that have come out here over the last 6 months that get deeper into this. A few actually just happened a couple weeks ago, so you guys can get some of that information out of the Spring One. You know, so there's been a lot of really interesting talks there around Knative and Riff and what that means for us as developers, you know, and then what that means ultimately for services like PFS. Well, folks, thank you so much. I appreciate your time and attention today. I will mill about if you have questions and comments, but I do hope you enjoy lunch. Thank you.